Today, we're gonna learn how to turn this into this.
We're here today with Dr. Jaron Hansen from BYU's Chemistry Department. He's going to tell us why we were shoveling manure back there. So, Dr. Hansen, what were we doing?
First of all, Katie, I want to thank you for your efforts in shoveling all of this waste. We could use it. The more you shovel, the more renewable energy we make from our process. Briefly, this is the way this works. We take waste from a number of sources. It can be waste from a confined animal operation, manure. It can be human waste. It can be food waste or garbage. We take this waste, and if needed, we pre-treat it. The pre-treatment simply just makes this waste more amenable to being broken down by the bacteria that are housed inside of our anaerobic digester. The anaerobic digester then converts this waste into methane gas. That methane isn't very pure though, and so we've had to invent a device to purify that methane gas, and that's the device that's here behind us. That's a Biogas Conditioner, and its job is to scrub out the impurities that are in this gas. Once we do that, then the gas can be used, we can burn it to make electricity, we can compress it to make compressed natural gas, or alternatively, we can even convert it into liquid fuels, biodiesel if you will.
So can we go check it out?
Yeah, let's go look.
While Jonathan went to learn about anaerobic digestion, I met up with one of Dr. Hansen's students, Mackenzie, to learn about how she pre-treats some types of waste before they get digested.
So there are some things that the bacteria in the digester can digest really easily, and there are some things that it can't. So if we want to use substrates that the bacteria can't digest very easily, then we pre-treat them to break them down a little bit before we feed them to the bacteria so that they can digest them.
Okay, so what do you do to look at that?
So we'll take some grass.
Mackenzie let me try it out. I was surprised at how much she's able to contribute to such a large project, even though she's still just a student.
So once we pre-treat these substrates, we can test whether our pre-treatment method has worked by putting some of the pre-treated substrate in one of these vials with some bacteria, and then this goes to the calorimeter, and that's how we can tell whether the pre-treatment has worked.
After Mackenzie explained pre-treatment to Katie, I went with Taylor, another student, to learn about the digestion process.
So what we have here in this vial is our anaerobic digestion sludge. So it's our bacteria that we put into the vials and so that we can test and see how much reaction we're actually getting out of the sludge. So when we take this vial and we fill it with sludge and we fill it up with other material that we want to test and see how well that sludge is reacting with the material. And we use this instrument called an isothermal calorimeter that just measures the heat that's given off with the reaction. And so that we can see the difference between the two heat rates will give us how much that reaction with the sludge is occurring.
Once waste has been pre-treated and run through the anaerobic digester, the methane gas can be collected, cleaned, and used for fuel. Although Taylor and Mackenzie are pre-treating and digesting waste on a small scale, their research can be applied to industrial-sized facilities. One of Dr. Hansen's digesters is already in use in China, and another was recently installed in Provo, Utah.
These digesters could enable us to power cars, homes, or entire cities using just waste. Students with degrees in chemistry find careers in many fields, such as medicine, forensics, and engineering. Using their understanding of chemistry, they contribute to products and projects that shape our lives.
Hands-On is a production of the College of Physical and Mathematical Sciences. If you would like to learn more about any of the majors in CPMS, visit www.science.byu.edu.